thought I would introduce them, and I think they'll probably have a few comments, right? And then I'll basically turn it over to them, and I'll try to moderate the questions, but I'm guessing that they've done it so many times, they'll probably just take control and do it. But
hopefully get so it's that first icebreaker question that
I've got one here.
Okay, yeah.
Actually, I've got several here that.
Are those mics on, or will they turn them on and back?
They will turn them on and back.
They were telling me he actually did a Comic-Con.
What did
The administrator, he did a Comic-Con because he said he's popular with people like Star Trek and stuff.
Okay.
Yeah, we're going to do one here shortly.
Yeah.
So there's one in town
Yeah.
next week or something like that.
So he's like popular with because he's a space guy. It's kind of cool. I didn't think about it.
Mm-hmm.
Oh, is there somebody else somebody else is out there with a camera? I don't know who it is. I think it's Katie. There's somebody with a camera out there that's walking around here with us. I think they're waiting for the press conference. You're just taking them off. I didn't get a chance to talk to her yet. I don't know where she's at the moment. So. Do you need me anywhere? Okay, just want to say anything about it. I can take care of that real quick. So I believe everyone's kind of handed this in place, but I can double check on that.
Yeah, but it's just our team and
Yeah, we're gonna take. Yep, that's what I did yesterday when I went to Skies because it's a one-way going downtown.
it's a night.
Then we ran to a train last night. I thought I was going to lose it. I was like, we're sitting here 20, 30 minutes. It was fine. I was just like, I can't believe this. We're not even 100 feet from the hotel, and we have to wait for this train.
That's life in Grand Forks.
It is.
They need to build an underpass.
Yeah, I felt so bad. I'm like, I should have just used my instincts and just turned around, but we were committed into the lane at that point.
Should I? Were you were going to the hotel? And
Yeah.
Trying to coming into downtown.
No, this is when we're coming into the hotel. Everything's wrapped up, yeah. Because we were there perfectly on time. I was sweating it a little though. Yeah. Good thing I scouted it. Okay. I came up here. I scouted it this weekend. Last weekend. Or else I don't know. What disaster I could have done.
Well, the whiteboard is now.
There you go.
I want to be a
Yeah, just leave it off.
Do you need anything else from us?
I think we're okay.
Okay.
We won't know. Yeah, we won't know where we are until it happens.
Right.
We'll be fine. get you mic'd up here.
Okay. Some high-tech person's gonna
Right.
clip my mic on.
Oh, we gotta do mics, huh?
Okay, you on the right?
Can you use that? Well, why don't we put it on the right, since I'm facing.
Well, I mean, chair-wise.
Oh, I'll sit here and you'll, he should sit with his logo.
My logo?
Huh? Yeah, I think so.
You do. Put on your tie.
Yep.
Right about there.
Right.
Assume it's stuff that you've seen and heard before. Actually, we're gonna put it to the other side of the tie.
Oh, good.
And bring it up just a little bit. We'll work with it. And this can be just clipped to your belt.
How is this on mine?
Just fine, thank you.
You already have it hot, so you can.
Nope, I don't. Nope. Now it's hot. Yours is hot
You'll
also.
get a check in the back, don't you, David?
Cool.
Yep, so we just need one of you to start talking so we can get a quick sound level check.
Test 1, 2, test 1, 2. Can y'all hear me back there?
Keep going, you
Awesome.
like Lee?
Lee.
Okay.
1, 2, 3.
With malice toward none, with charity for all, with firmness in the right, as God gives us to see the right. Can you hear me? Okay.
All right. And you,
And Lee, can you hear me? Great,
all
thank
right,
you.
we're all set to go.
All right, folks, welcome. We have with us today Senator Kramer, Senator Kevin Kramer, and NASA Administrator Jim Bridenstine. Let me do a couple of introductions briefly, and then move into the show, if you
Sure.
will. So, Senator Kramer elected to the Senate this past November 18, and served on the Senate Armed Services, Environment, Public Works, Veterans Affairs, Banking, Housing, Urban Affairs, and Budget Committees. Has made a constituent outreach a top priority prior to going to Congress. Served several years in the state government from Kandu.
Well,
North
my
Dakota.
daddy's from Kandu, my wife's from Kandu, and I'm from Kindred.
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 Sorry. And Senator Kramer invited his, we find out now, invited one of his classmates, congressional classmates, now NASA Administrator Jim Bridenstine. Both of you entered Congress in 2012. I lost the date here. Since then, Mr. Bridenstine has been the NASA Administrator since April of 2018, and I will say that I think we're perhaps kindred spirits. We are both naval aviators, although he flew F-18s, and so, and I flew
Everything?
everything.
He was a test pilot at Pax River Naval Air Station, so there's not many things you haven't flown.
That's true.
That's
That's true. So, for you, this is a representative audience of aerospace, across aerospace. So we'll have students and faculty and staff from ESSP, Earth System Science and Policy, from atmospheric sciences, from aviation, and of course from space studies, and a few folks from outside the Odegaard School. Just to bring you folks up to date, because this will give you a sense for where they've been. Today we've seen the altitude chamber, the atmospherium. We spent some time in the habitat, the lunar Mars, analog habitat, and some time in the spacesuit lab. So welcome to the best aerospace school in the world. And
No bias.
and I would say, with respect to space studies, the first and global leader in graduate interdisciplinary space studies education.
Yay.
So with that, I trust that you perhaps have some remarks that you'd like to make early on, and then we have Q&A.
Yeah.
Okay.
Yeah. If I could just, I'll start because I'm suspicious that this will be the last thing I get to say. Because I would hope that with Jim here, you have a bunch of questions for him. I love enthusiastic faculty, and you should certainly have them. And you have a good chairman, obviously, a good dean, a good interim president. We've dined with them all now, a couple of meals as well as the tour. And I think for my part in all of this, the chairman said it pretty well, Jim said it pretty well. Jim and I were classmates. We came into Congress together in 2012. His cubicle was right next to my cubicle in the basement of Rayburn before we got our real offices upstairs. And so in December of the election year, we came in together and met each other. He might be the first classmate I met, actually. And we've been friends ever since. We also both served on the Science, Space, and Technology Committee as freshmen, and Jim sat right next to me. And I was really good at cross-examining environmental and energy witnesses, and he was superb at cross-examining everybody. And Jim's a very smart guy. He's got 3 degrees from Rice. He's got an advanced degree from Cornell. Besides being a Top Gun naval pilot and Patriot, he's served actually managing a space museum and a planetarium in Oklahoma. But more than anything, he's a really good friend. And when you go to Congress together and your classmates, particularly from Normalville, USA, like we're from, you sort of gravitate to one another. And we've had a lot of fun. And I think hopefully you all have experienced that we continue to have a lot of fun, even in the very serious business of governing this country. And so when Jim was appointed to NASA administrator, I could not have been more delighted. And a lot of us were pleased by the president's decision and grateful that now he serves. So then, of course, I invite him to come to Grand Forks. And what you should know is, I don't know what he's going to say about his dates so far today, in his last evening, but he talked to me about this institution before coming here. He told me about the times that he's been to Grand Forks swimming as a young swimmer. He's an excellent state champion swimmer and nationally ranked swimmer when he was in college and high school. He talked to me about the spacesuit program as the NASA administrator before coming up here to see it. And so, just so you know, your reputation is far and wide. I wanted to say at the outset how grateful I am that you're here, Jim. I mean, to us, while we take a backseat to no one, I agree it's the best in the world. We appreciate, it's a long ways from a lot of places, and we appreciate company, we appreciate visitors, and it serves as an encouragement to us that you're here at all. And I think it serves, hopefully, as an encouragement to you students, especially, that you have this moment, eyeball to eyeball with the administrator. I would just tell you this, for those of you who have taken political science or haven't, this is the value of 2 senators from every state, including the little places, because we get to have an intimacy with each other that my colleagues, quite frankly, don't enjoy. And so this moment is really for you. And with that, I just thank you, Jim, for being here. Thanks to all of you for the irrevocable gift of your time today.
Well, thank you, Kevin. Senator Kramer, thank you so much for that. It's an honor to be here. As Senator Kramer mentioned,
my mom calls me Kevin.
we have been friends. We got elected to the House of Representatives in 2012. We went through orientation together in the House, and then we served on the Science, Space, and Technology Committee together for a while. And Obviously, Senator Kramer went up through the ranks much faster. He left the Science Committee, went on to Energy and Commerce, is that what it was? Which, of course, is what they call an A committee because it's supposedly more important than science, but I'll tell you this, in my view, I like the Science Committee. Then obviously we took different routes. I went to NASA, he went to the Senate. So now he's kind of like my boss. He's one of the people that funds my agency. So now he gets to call me and say, hey, why don't you take a trip to North Dakota? And my answer is, yes, sir, we'll do that. We'll be there. We'll be there next week. When do you want me there? And, but I will tell you, Senator Kramer has been a good friend for a long time. He loves the University of North Dakota. He knows what goes on here and how important it is to our space program. He's been a supporter of really key things. People wonder, and people talk about NASA, and we have these 10 centers all across the United States of America. These 10 big centers. But one thing that is unique about NASA is that we have these great relationships with universities. And in the university setting, we can do things that you can't do in many other cases. We have the scientists and the engineers. They work side by side, and they make those trades early in the development of a program. The way you engineer something ultimately changes the science you're going to get from it. And of course, the scientists can provide feedback to the engineers can provide feedback to the scientists in real time. The goal ultimately is to produce something that ultimately remains on cost and on schedule. That's the objective. And universities have a way of achieving that is very unique because universities make those trades early, and universities also take advantage of resident talent that's already available, plus universities get students involved. And all of that conspires to provide something tremendously valuable to NASA. And today, of course, we've been touring the University of North Dakota, and we've seen all kinds of activities from the atmospheric sciences that happen here, the numerical weather modeling, how do we get more data, better data, how does NASA partner with the scientists at the University of North Dakota to get more data and better data into our numerical weather models, how do we modify our numerical weather models so we can get better weather information, better predictive capability in weather. University of North Dakota is very involved in those activities. Of course, we spent time today out at the Mars Analog, big habitation center, which I'm sure everybody in this room has seen and been a part of. But what a really cool experimentation for habitation on another world. Human factors, critically important. If you're going to live for long periods of time on another world, how do you train for that? How do you prepare for that? How do you learn how to live and work on another world? Well, that's what that Mars Analog facility is all about. And of course, that's a grant from NASA that helps us understand ultimately what we will be facing when we spend a lot of time on the moon and then, of course, on Mars. And then, of course, the spacesuits. Everywhere I go around campus, I see, I don't know if you guys have seen this National Geographic, but everywhere I go, there's a picture of the National Geographic with the North Dakota spacesuit. They call it the centerfold of National Geographic. What an amazing capability that is here. I will also tell you, when I was a Navy pilot, I flew with a number of people who are graduates of the aviation program here at the University of North Dakota, some of which are still my very good friends. So I can tell you this little university up here in Grand Forks bats well above average and is doing great things, not just for NASA, but for the country. And I look forward to continuing this great relationship between the university and NASA and making sure that we're able to do more than we've ever been able to do before. With that, we have, how much time do we have? We have about an hour, is that right?
Yes.
50 minutes remaining?
About 50 minutes.
So I'll just open it up for questions and answers and thoughts and concerns. And I'd like to hear what some of your thoughts are. If you have questions, happy to answer any questions that you may have as well.
And if you would please use the aisle mic so that we can, we're recording here, so we can hear the question.
You bet.
So, Wayne, great.
Hi, I have a question related to the new program of going to the moon and beyond.
You bet.
I'm old enough to be disappointed from what happened essentially in the 1990s with George Bush Sr. and then his son later on announcing that we're going to do this grand thing and returning to the moon and on to Mars. And it seemed to me it was the lack of financial support, bipartisan, that led to the failure of those programs in some sense.
Right.
And I'm really curious of what the other side, the Democrats, to be frank, how do they support this new initiative that NASA and President Trump, has started? Is there any support there? And if not, it's really disappointing. As somebody who's been a space nut, if you like, since he was knee-high to a grasshopper, I'm still waiting and waiting for us to take that next step. I'm celebrating 50 years this summer of landing on the moon. Even though it was a very joyful event, it actually brought tears to my eyes thinking of what we could have accomplished in the last 50 years, our potential.
Great question.
So, a couple of things. We have seen hundreds of thousands of people on the National Mall before. The 50th anniversary of Apollo, there were 500,000 people on the National Mall, and the difference between, July 20th, 2019, and every other time I've seen hundreds of thousands of people in the mall is that these people were all happy. and they were joyous and celebrating, and they were bipartisan, and they were diverse. This was a group of people that represents all of America, and they were celebrating this stunning, monumental achievement from 50 years ago. It is even today capturing the imagination of not just the American public, but the entire world. And as you correctly identified, we have been through this before. In the 1990s, they called it the Space Exploration Initiative. We're going to go to the moon and on to Mars. The challenge that we dealt with in the 1990s is that it was suggested that we fund this by taking the money from the International Space Station. Well, if you want to kill a program, go after the Texas delegation, or go after the Florida delegation, or the Alabama delegation. That's how you kill a program, because it's not partisan at that point, it's purely parochial. And because that's what the concern was, you're correct. It never got the support it needed in the House, it never got the support it needed in the Senate, and ultimately it never got funded. Then we go into the early 2000s. We had the Vision for Space Exploration, which was a return to the moon and then on to Mars again. This time, NASA created an amazing program to accomplish all of these things, amazing engineering, amazing technology, but ultimately it was going to be funded by cannibalizing the Science Mission Directorate of NASA. Again, if you want to kill a program, that's how you do it, because that creates a partisan fight. Not a parochial fight, but a partisan fight. And it's not even, it's bipartisan. People believe on both sides of the aisle that NASA should have a strong Science Mission Directorate. So both of those policies ultimately failed. So we put together a plan to get to the moon. The president gave us Space Policy Directive 1. There's a number of things in there. Go to the moon. Go sustainably. In other words, this time when you go, stay. He said, use commercial partners, which didn't exist in either of the previous scenarios. Use international partners, which, by the way, also didn't exist. We did not have all of the years of experiments with the International Space Station. He said, utilize the resources of the moon, which is, again, that's a brand new policy, but that gives us the ability to stay for long periods of time and use the resources of the moon to live and work on another world. And then the final piece in Space Policy Directive 1 is ultimately take what we learn and go to Mars. Mars is the destination. The moon is the proving ground. It's how we learn how to do these activities in a place that is a 3-day journey home, which means you can safely come home. So we go to the moon, and then we go on to Mars. The moon is the proving ground. Mars is the destination. And all of this is embedded in Space Policy Directive 1 from the President of the United States. Now, it is true that we have to learn the lessons of history. So I made sure we put together a budget proposal that accomplished those objectives, but did so without cannibalizing the International Space Station, learning the lessons of history, did so without cannibalizing the Science Mission Directorate, and by doing that, we had an agenda to land on the moon. We could put it together, so we could have the first, or I should say the next person on the moon in the year 2028. Well, the president and the vice president saw that, and they said, that's not good enough. We're not going to wait around. Because one of the reasons these programs get killed is because they take too long. When you have to go from administration to administration to administration, and by the way, from Congress to Congress to Congress, with changes in leadership in both places, this is a risk. So NASA has been really good in the past. We've been really good at retiring technical risk. That's what we're good at, and we can do it. And I'm telling you, we have the best scientists, the best engineers. Technical risk is our forte, and we can retire that all day, every day. What we are terrible at as an agency is the political risk. Calculating ultimately, because we are a political agency, we are funded by the senators and the House members that ultimately are the leaders of this nation. And of course, we get our direction from the president, the executive branch. So, and of course, he signs bills into law that come from the House and the Senate, the balance of power. So all of this conspires to say that we have to be, it's not just science, it's political science. We have to be good at the political science. And so that's really what I've been working on. This is the August recess. And what am I doing? I'm traveling the country, meeting with members of Congress and senators on both sides of the aisle that are critically important for achieving this agenda, which is to go to the moon sustainably for the purpose of getting to Mars. And I will tell you, we do have very strong bipartisan support. I would encourage you to follow me on Twitter, because I have, in fact, we have done these kind of events across the country with people that support us on both sides of the aisle. In fact, last week, Monday,
I was hoping you'd go there.
yeah, last week, Monday, I was in Northern California doing Women's Equality Day with Anna Eshoo, who's a friend of mine from the House, and Speaker Pelosi. And they're both very supportive of the Artemis program. We are calling the agenda to go to the moon by direction of the president, given at the National Space Council through the vice president. The direction is to accelerate the program from 2028 to 2024. And I have made clear that if we're going to do that, we're going to need additional resources, because we can't get the money by cannibalizing these other programs. It won't work. But the direction was also to land the next man and the first woman on the South Pole of the moon, which we've never gone to the South Pole. By the way, because we haven't been to the South Pole, we missed for 40 years, from 1969 till 2009, we had no idea that there's hundreds of millions of tons of water ice on the South Pole of the moon. We thought it was bone dry. And here we are, 2009, we find this massive discovery. It should have immediately changed our program. We're now getting it changed. We're going to go to the moon. We're going to utilize that as a resource. It's life support, it's air to breathe, it's water to drink, it's rocket fuel, all of that available in hundreds of millions of tons on the South Pole of the moon. So we're getting that fixed. But at the end of the day, I told the president and the vice president, and they agreed that we need additional resources. And so they backed us up. They said, if you want to go in 2024 instead of 2028, accelerate the program, retire or reduce, I should say, reduce the political risk. If we're going to do that, we're going to need additional money. And they provided in an amended budget request, which is unusual, but they amended the budget request to include an additional $1.6 billion focused on a lunar lander system, which is necessary to get to the moon. So you take what we were going to do in the years 25 to 28, you take that activity and you accelerate it forward. We needed $1.6 billion additional in the year 2020, and they were able to provide that in a budget request that didn't take the money from any part of NASA. And now we're talking to members of Congress on both sides of the aisle, and we're getting strong support. And what you'll find is there are people that support it for different reasons all over the country. In Northern California, NASA has the Ames Research Center, and they do really good science on the moon. And they have rovers that are going to go to the moon and help us understand how do we utilize that water ice? How do we characterize it? Where is it and what volumes? And so they're very interested in that. And so there's a lot of scientists that are interested in it, but there's a lot of different people that have different reasons for wanting to go to the moon. But I can tell you, and I think the senator would recognize, that space has a very unique way of uniting people. And it's positive. And by the way, it's not new. When we go back to 1975, 1975 was the first year that the United States of America and the Soviet Union partnered in space, the Apollo-Soyuz program, in the height of the Cold War. Of course, that was after Apollo, but after Apollo, we decided we were going to partner on these activities. We had the Apollo-Soyuz program. Then we followed that with the Shuttle Mir program, Space Shuttle and Mir. And then we followed that with the International Space Station. And now on the ISS, we've had Russians and Americans working side by side for almost 20 years. In fact, there's people in this room that are probably were not even born when we started flying together on the International Space Station. That's all very positive, but it doesn't just bridge the geopolitics, it also bridges the American politics. We have support from both sides of the aisle. We saw that when we celebrated the 50th anniversary. My goal is to run the agency in an apolitical, bipartisan way, so that, because these programs, they have to be multi-generational in nature. We're talking about exploring space. It doesn't end. We have to keep going, generation after generation, learning step upon step. And so, look, I will tell you, as the NASA administrator, I'm working very hard to make sure that we have support on both sides of the aisle, that it's apolitical, bipartisan. We don't make the mistakes of the past. I can't promise you what the outcome is going to be, but I can tell you we're working really hard on it.
If I could just add a little to it. First of all, Jim, I think it'd be helpful and encouraging for them to hear about, this is a big hockey school, so tell them about Canada's recent commitment, because I think it speaks to both of these issues.
That's great. Interestingly, Canada has recently stepped up. We said we're going to go to the moon. We need to build in orbit around the moon something we call Gateway. It's a space station in orbit around the moon that's going to have a design life of 15 years, which means it's probably going to go much longer than that. So when we talk about the Gateway, think of it as a reusable command module in orbit around the moon, a space station in orbit around the moon, and it's going to need, we're looking for international partners. And we're building on the foundation of the International Space Station. So the first partner that stepped up was Canada. And Canada stepped up with not just a commitment for 4 years, which, by the way, is the history. They stepped up with a commitment for 24 years. And they did it as soon as we announced the program. They were the first country to the table. In a couple of weeks, I'll be heading to Japan, where we're going to enter into an agreement, knock on wood, with Japan to do these similar activities. And then, of course, the European Space Agency has an interest. Russia has an interest. So all of these different countries are now stepping up to the plate in a major way. And so space really does have this ability to unite. I cannot overstate how important space exploration is as a tool of diplomacy for the United States of America. It really does represent that. So it's a good question. Know that we're working on it.
On the funding side, I might just throw out a little tidbit just for everyone to noodle. Artemis is thought to cost about $30 billion to see all the way through. The Kennedy vision, the Apollo vision, I suppose you could say, in today's dollars would be $288 billion. So there, we've learned a lot, and I think we oftentimes miss the context, the historical context of some things.
We have huge advantages today that they didn't. The miniaturization of electronics, the ability to store power in batteries for long periods of time with less mass than ever before. The ability now we're seeing reusability built into the rocket launch capabilities, whether it's Blue Origin or SpaceX or even the Vulcan rocket, which is United Launch Alliance. Well, we want to build that reusability into every part of the architecture between the Earth and the Moon. So the landers that are going to go from the Gateway, the space station in orbit around the Moon, those landers themselves are going to be reusable. They can go back. And by the way, they could very well be refueled from the water ice on the Moon. The hydrogen and oxygen embedded in the regolith in hundreds of billions of tons, hundreds of millions of tons. Although there's probably a lot more we just don't know yet. So anyway, yeah, all good stuff.
Okay, Jared?
Thank you both for being here today. It's great to hear from both of you. My question revolves around human factors, and as we move farther away from Earth, we will have astronauts that will be needing to rely more on their own intuition, their training, without the help of mission control in real time. So how is NASA preparing astronauts during training right now to address greater crew autonomy, solving problems, making their own decisions?
That's a wonderful question. We are investing in the University of North Dakota for the Mars analog habitat. But the reality is your point is very well taken. Mars is an entirely different problem than the moon. The value of the moon is that it is always with the Earth. Wherever we go, it goes with us no matter where we go. Mars is in an orbit of its own around the sun, and the window to get to Mars is once every 26 months, which means, number one, when we're ready to launch, we got to be ready to launch. We can't miss the launch date. And number two, when our astronauts go, they're going for a long period of time. Because by the time they land on Mars, there's not going to be a way to get home. They're going to need to learn how to live and work on another world for 2 years before they have an opportunity to launch back to Earth. Because Earth and Mars are going to be on opposite sides of the sun halfway through that 2-year period. All that being said, the way we learn how to do this is a stepping stone process. We start with the International Space Station, which is a great experimentation system for us to learn how to live and work off the world for long periods of time. Human physiology, all of the way, the human psychology, I mean, that's a big challenge in itself, and talk to our astronauts about that. 6 months in an isolated environment like that, microgravity, and all of the changes in your body that happen during that time, it's a big stress on our astronauts. But it starts with the International Space Station. The next step, of course, is the moon. The moon is the proving ground. And of course, we will learn on the moon how to live and work on another world for long periods of time. And part of that is going to be autonomously. How do you do that without support coming from the Earth? Because we could stay on the moon with support coming from the Earth, but that doesn't help train our astronauts for an eventual mission to Mars. So I think the right step is to use the moon as that proving ground, and then ultimately be ready to go to Mars. But you're absolutely right. The idea that we are ready today for that activity is incorrect. We've got a lot to learn, and we're using, in fact, great universities like this to help us learn that activity. Do you have any thoughts, concerns?
I think more along the lines of the communication delay
Yeah.
would have too, not just how long it would take to get home, but in fact, up to 20 minutes of time. It's basically as good as sending an email and then waiting for that response. And a crew's mental ability to really contain all of their training, everything they've learned through the hours of training, will be difficult to perform in a Martian environment. But those are just considerations we need to work on, and certainly something in our capacity, I believe.
So it's interesting. The communications delay is obviously significant, and when you're on opposite sides of the sun, there's a communications blackout entirely for I don't know how many days or weeks, but it's a good bit of time. And so yes, there is a significant challenge there. What that means is you can't really do telerobotics. You can't remotely control things on the surface of Mars from the Earth. And so you're going to need more autonomy in the robots that are assisting the humans on Mars, for example. It is also true that the gateway, remember what the gateway is, space station in orbit around the moon. Well, the space station in orbit around the moon, the gateway, it's all about access to the moon. We have a lander there. We're going to have multiple landers there, potentially, that are going to be going back and forth to the surface of the moon over and over again with a reusable architecture, which didn't exist in the 1960s. But we also have to remember what the gateway also does. It is an architecture that as much as possible can be replicated at Mars. Entry, descent, and landing is entirely different because of the Martian atmosphere. But we can have a gateway in orbit around Mars with low latency telerobotics capabilities. So there is no reason you could not have a command and control element in orbit around Mars while we have activities on the surface of Mars, and potentially even multiple different surface activities all at the same time on the surface of Mars under one mission. So these are all capabilities that are important. The telerobotics are critical. If we're going to do low latency telerobotics, we need to have, of course, the gateway in orbit around Mars. But I'll tell you one thing that's even more exciting, quantum communications. The idea that you can entangle subatomic particles. electrons, for example. You can entangle them. And then you separate the electrons on one side of the solar system to the other side of the solar system. And if you spin this electron to the left, this electron spins to the right, instantaneously, automatically, without any communications between the two, and you can separate them on opposite sides of the solar system. Einstein called it spooky. It is spooky. And by the way, it's not just within our solar system. You could do it on opposite sides of the galaxy. You could do it on opposite sides of the universe. This has a capability to transform communications for all of humanity in a way that, by the way, if the United States of America is not first in developing this, it will change the balance of power on Earth in a not so good way if we're not first. Because that kind of communication is not jammable, it's not spoofable, it's not hackable. You wouldn't even know that a communication took place, let alone that be able to jam it. And so it's transformational. We need to master that. NASA has a role here. What is our role? NASA's role is, okay, well, if we need to communicate from Earth to Mars instantaneously, there's a reason to do that. If we want to send astronauts even deeper in the solar system, which we do, you have to have that kind of communication capability. We need to master it for a whole host of strategic reasons. NASA plays a role here, but we also need to do it for science reasons as well. But we can fix that latency problem with traditional wavelengths.
I appreciate it. Thank you very much.
You bet.
Sean?
Good morning. Welcome to UND. I'm Sean McClung, a PhD student from the Space Studies Department. I have a bit of an open-ended question, but based on the answer to the first question, I don't think that's going to be a problem. In the Space Studies
Are you
Department,
saying I talk a lot?
He knows a lot.
you give very informative answers to a broad range of
You should
topics.
run
How
for
about
something.
that? There you go. You've commented earlier in your introduction about the synergy between the science and engineering. A lot of what we do with space studies, we have the really good engineering with the human spaceflight and the spacesuits. We do a lot of good science in the planetary science and astronomy fields. But the real strength, I think, from the department comes from the interdisciplinary connections between not just the science and engineering, but also connections to private spaceflight, to space law, and all of the implications in between those ideas. So in your position as NASA administrator, where are some areas for the potential synergies between these areas that are perhaps untapped, or that we can, as young students entering the space workforce after this, can really try and seize into?
This will be a very thorough answer, I guarantee you.
No, so this is good.
Wheelhouse.
You're asking the right questions, because all of these have to do with the future. And when it comes to space exploration, the future is undefined and very broad. You're talking about the partnerships. I will tell you, if you look at the way NASA historically does contracting, we had this conversation last night at dinner. If you look at the way NASA, I've got it on me, it's on me, to land the next man and the first woman on the south pole of the moon by the year 2024. I've got 5 years to get that done. Now, if we go through the way we do contracting as an agency, here's how it starts. NASA spends 6 months trying to think up all of the information that we need. And then we put out a request for information, and we wait for 6 months while industry and academia responds to all of that request for information. Then once we get it, we spend 6 months looking at that information and trying to create a request for proposal. And after 6 months of evaluating all the information, we put out a request for proposal. Then we wait 6 months, and we get proposals back from industry. And then we spend 6 months looking at all those proposals and making a source selection decision. Then we put out a source selection decision, and then all of the people that didn't get selected protest, and then the lawsuits happen, and then it gets tied up in the courts, and 4 years after we decided to land on the moon, we're under contract. Well, I've got 5 years to get to the moon. That's not going to work for me. So we've got to do things differently. Well, how do we do things differently? In many cases, we can actually buy services using other transactional authorities rather than purchasing, owning, and operating hardware. We're doing that right now on the International Space Station. We have partnerships with SpaceX and Northrop Grumman to resupply the International Space Station, which has been very, very effective. We have partnerships with SpaceX and Boeing to do commercial crew to the International Space Station. Boeing with United Launch Alliance providing the rocket. So So those elements are being commercialized already. The idea is NASA's buying a service. We're not purchasing, owning, and operating the hardware. The idea being, this is the important point. What is the vision? The vision is NASA needs to be one customer of many customers in a very robust commercial marketplace. And we need to have numerous providers that are competing against each other on cost and innovation. If we can achieve that, we're going to be able to do more with less than we've ever been able to do before. So we're doing that right now with commercial resupply to the International Space Station. Now we have commercial crew to the International Space Station. Right now we're using the space station to commercialize activities that are going to transform human lives on Earth and will result in commercial habitation in low Earth orbit. The more we can commercialize activities in low Earth orbit, NASA becomes a customer, not the landlord. And when we become the customer, not the landlord, we can take the valuable resources that we get from our senators and representatives, we can take those valuable resources and we can do things that there is not yet a commercial marketplace for, like go to the moon, like go to Mars, always with an eye for eventually commercializing those activities as well so that we can then take our resources and go further. So those are kind of the partnerships that we're looking for. Now, when we talk about the moon, we talked about the gateway. The gateway is the space station in orbit around the moon. We're going to have landers at the gateway that go back and forth to the surface of the moon. The way we are procuring that is as a service. We're going to say who can take our astronauts to the surface of the moon and back to the gateway for a fee. Think of Uber in space. That's what we want to do. And if we do that, we won't spend so much time going through this process by which we get bogged down and can't get where we need to go. So I think those partnerships are important to understand. You mentioned specifically space law. Space law there's so much involved in that. And it is so open right now. I will tell you, one of the things we did in the House back in 2015, were you on the Science Committee then? You were already gone? Back in 2015, we authored a bill called the Space Act, and what it did is it very clearly defined resources on the moon and the fact that they are available for use by humanity. In other words, if you go back to 1967, the Outer Space Treaty says that the moon shall not be appropriated for national sovereignty. So then people say, well, then you can't use the resources you find on the moon. The water ice, you can't use it because that would be not, it's not. A private company can go to the moon, extract the resource, and then not appropriate the moon for national sovereignty, but have rights to the resource. It's a lot like oil and gas in, say, the Atlantic Ocean. A company can extract the resource, but the company doesn't own the ocean. They just own the resources. When you apply your labor and when you apply your investment to the activity, then you have the rights to that resource, even though you don't own the ocean. And in this case, you can own the resource, but not necessarily own the moon, if that makes sense. So I think that's one area where Congress gets involved from time to time and specifically interprets for the U.S. government the meaning of the Outer Space Treaty, which, by the way, I support the Outer Space Treaty. But we need to start putting some definition to it that back in 1967, it didn't matter because nobody was going to extract resources. The other thing that's important when you talk about space law, in my view, we talk about rare earth metals on Earth, and China has a bunch of them, and they've said they're not going to sell them to the United States anymore. Well, that's very disruptive to technology in the United States of America, very problematic for us. Well, those rare earth metals are not earth metals at all. They're asteroid impacts from billions of years ago. And those asteroid impacts are not where they were billions of years ago because we have this very active geology and a very active hydrosphere and a very active atmosphere. And when we look at all of this activity, we say, okay, well, it's trace when we find it. That's why they are rare earth metals. Well, the moon doesn't have an active geology. It doesn't have an active hydrosphere. It doesn't have an active atmosphere. Anything that impacted the moon 1 billion years ago is today right where it was 1 billion years ago. Which means there could be trillions of dollars worth of platinum group metals on the moon. Do I know that? No, I have no idea. But guess what? Neither does anybody else. But to the extent that somebody finds it and goes after it, it will again change the balance of power on Earth. So we have to make sure that we are preeminent, that we are first, that we are enabling our industry to go forth and do that activity. I think it's important. You know, Goldman Sachs did a study not too long ago, and they said in their study that the world's first trillionaire is going to be somebody who does asteroid mining. I see an asteroid scientist back there clapping. That's right. That's an interesting take for Goldman Sachs, because they, of course, are looking at all kinds of investments. So anyway, we have to get the law right. There's so much that goes into the law. What I would recommend doing is look at the space policy directives that have come from the president. There's a good number of them. The first one is about going to the moon. The second one is all about the regulatory environment. How do we make sure that the United States of America with commercial industry can compete against nation states? I mean, that's a challenge. So we have to deal with the regulatory environment. The third one is about space situational awareness and space traffic management. Again, that has to be protected, and if we don't, then we're going to lose access to space altogether. Some enemies of the United States might think that's a good idea. We don't. And then the fourth one is about the Space Force, which, of course, in my view is important. By the way, when I was in the House, we voted on the Space Force. The Space Force, when I was in the House, it got 344 votes in a bipartisan vote in the National Defense Authorization Act. It went to the Senate, didn't make it through. Now we have a senator there that's been very helpful on this issue. And by the way, he's been a champion on this issue for the right reasons. And because of that, the Senate actually passed a bill on the Space Force that's better than the House bill, and the House started this whole process. So we're in good shape because of Senator Kramer. But space law, big topic. I would look at the space policy directives from the president, and then you can let your imagination go, because it is so undefined. And it opens up so many possibilities.
Okay, so this is where I just have to say a couple of things, because you asked the perfect question, he gave the perfect answer, and I'm telling you, we're likely to screw it up. So except that we're having this discussion. Because if you you pick an act, the Clean Air Act, Clean Water Act, highway bills that are 5 years, any of these broad authorizations, we think we've thought of everything when you pass a bill. Except what we oftentimes don't do, while we have definitions for for navigable water as an example. What we don't do is we don't define what things are not. And if you're not prescriptive in the law, that leaves way too much room for mischief, shall we say. So particularly because we do have competitors in this. It's not, while international space stations are great and while an international effort is paramount, not everybody's on board. There is a race here. There is a race. And that's why I think we have to always be careful about how specific we get, how prescriptive we get. I think the thing that's most encouraging, and for those of you guys who've been interning at Kennedy, when you think about, those of us that are old enough to remember, certainly Apollo, but then even Space Shuttle. Now when you go to Kennedy, it's like a space commercial park. First you go over to this building, you take a tour of Lockheed Martin. You go over to this building, you take a tour of SpaceX. Well, if you go out to the Apollo launch pad, you get to see SpaceX. Or you go over to this building and you're over at Boeing, and on they go. That relationship that Jim described and the transactional sort of authorities that they can utilize is paramount to this being successful and it happening in real time. Because I still haven't been able to get the General Services Agency to move me into the office in Bismarck that I've had for the last 6 years. But because I became a senator, I'm just telling you, the bureaucracy will screw it up every time if we don't have very clear guidelines and utilize the expertise of the private sector.
Thank you.
Space law, in my view, has a huge. There's a need for big thinkers, and eventually there's going to be a strong need for action. And it is international in nature, so we've got to figure it out and make sure that our interests are protected there.
Conrad.
Hi, my question is about the International Space Station and what we're receiving from it, and will it still be useful in 10, 20 years with programs such as Gateway and Artemis?
Yeah, that's a good question. So the answer is 10, 15 years, I'm not sure. I'm hoping that in that time frame we will have half a dozen commercial space stations in orbit around the Earth. And the International Space Station, as it is, will be ready to move on. I mean, the reality is, we all know it can't last forever. There is an engineering limitation to how long this thing can last safely for our astronauts, and we need to keep that in mind as we think about the future. Well, the other thing that's important, and the senator can help with this, the other thing that's important, we got to make sure we look at what happened after Apollo, and you obviously brought this up. When Apollo ended, we had nothing to follow until we had Shuttle. So we had a period of 8 years of a gap of human spaceflight capability. And then after Shuttle now, we've had another 8 years of a gap, and we don't have commercial crew ready to go yet. So we've got to make sure we don't have these gaps. We need sustainable presence. That's why we need strong bipartisan apolitical support. It's why we need to tap into the commercial markets, the sectors that the senator just talked about, because they have customers that are not NASA. So when that happens, then we have sustainability. When we go from program to program, commercial applications continue to go forward. So we need to use the space station for those commercial applications. But what we can't have happen is we can't have the space station end without commercial habitats ready to go. And of course, the University of North Dakota here does really great work with habitation. Of course, the Mars analog is a great example. But the key is right now the space station needs to be used specifically for activities that have breakthrough capabilities for Earth. Come on in, have a seat. So I'll give you a perfect example. I think a technology that has amazing promise, although we're not there yet, is retinal implants. So right now we are proving on the International Space Station that we can create retinal implants in a microgravity environment in a way that the materials have to be layered in a way that you cannot do in a gravity well. You cannot do it on Earth. You can do it in space, on the space station, but you can't do it. So what we need to do is we need to master that technology, that capability. Once it's mastered, we need to be able to mass produce retinal implants. And so what this does is it says there are certain forms of macular degeneration where people lose their eyesight. Well, we can permanently end that if we're able to master this kind of activity in a microgravity environment. And by the way, when you look at Medicare, that reimburses to the tune of $75,000 those retinal implants. So if that's the case, the business case closes. If you can create a box that's this big that can create 1,000 retinal implants in a 6-month period on the International Space Station, that box comes back to Earth, and now you've got a whole host of retinal implants ready to go. That's the kind of transformational breakthrough that leads to commercialization of habitation in low Earth orbit. But it's not, retinal implants just one thing. Right now we're proving on the International Space Station that we can use adult stem cells to print human organs in 3D. When we try to do that on Earth in a gravity well, the tissue just goes flat because of the gravity. And of course, flat tissue doesn't help depending on what the tissue is that you're trying to create. You need it to be a specific shape. Well, what we're proving on the ISS is it will grow in the shape you need it to grow in a microgravity environment, then you can bring it back to Earth. Well, there's a habitation purpose in low Earth orbit that will be transformational for human lives on the Earth. We talk about material science. So that's the goal that I talk about there is industrialized biomedicine. People are familiar with pharmaceuticals, for example, but industrialized biomedicine is one line of effort that I believe will be transformational for human lives on Earth and lead to these commercial habitation capabilities in low Earth orbit. Also, though, it's not just industrialized biomedicine. It's also advanced materials. So we are proving on the International Space Station right now, fiber optics can be made in a very clear, crystal clear way. Z-band, other technologies. So if you can make fiber optics in a crystal clear way, you don't have to have repeaters every, I don't know how often they have repeaters, quarter mile, whatever it is. You don't have to have those repeaters. Well, if you don't have to have those repeaters, you drive down costs significantly, which means the business case closes to produce fiber optic materials in a microgravity environment that ultimately transform lives on Earth. There's so many other things, though. But know this, I really think that we are 3 to 7 years away from just one major breakthrough, one significant breakthrough that will be transformational for habitation in low Earth orbit. There will be a demand for it because there is going to be some technology that can be produced in microgravity that cannot be produced on Earth. And that's going to create this market, this demand. So what NASA is doing to prepare for that is we are moving forward with commercial crew, commercial resupply, commercial habitation. We want to be ready so when that day comes, NASA can become, we will have a presence. To be clear, we have a lot of science we need to do in the microgravity environment ourselves. We will always have a presence in low Earth orbit. We want to be the customer. Then we can take the resources that the senator gives us and we can go to the moon and onto Mars. So there's a lot of activities on the space station right now that I think are critically important for that commercialization effort. But we got to make sure we don't have the gap, though. We don't want the ISS to come to the end of its life without something ready to go.
Thank you.
Yes, sir.
My question is about space exploration.
Yeah.
So obviously we're doing a lot with the moon and Mars. What I'd like to know is things I'm more interested in, like what efforts are NASA making with like Europa and Titan and stuff?
Oh, my goodness. I can tell the clock just isn't going to do me well on this one. It's important. So the Science Mission Directorate of NASA has really 4 major focuses. One is heliophysics, the study of the sun. One is earth science, obviously the study of the Earth, which of course the University of North Dakota helps us with. The Global Precipitation Measurement Satellite that NASA operates, University of North Dakota helps us with the data to make sure that we're getting the good science that we need from that satellite. Then we have planetary science, which is the study of planets within our own solar system. And then we have astrophysics, everything beyond the solar system into deep space. And so those 4 divisions within the Science Mission Directorate, we have a lot of missions in each one of them. And those missions are tremendously valuable. I will tell you a story that I think is important. I think it was last February, China landed a lander on the far side of the moon, which had never been done before in human history. It was about the size of this table. They landed on the far side of the moon. And I got called to the Senate, as a matter of fact, to testify on how the United States fell so far behind. And I remember testifying that it is absolutely true that they landed on the far side of the moon. It's an amazing first. It requires a comm relay, but we could have done it. We just haven't had a mission to do it. But we landed, and then I testified, we landed on the far side as well of Mars. And we did it for the 8th time in human history. And we're the only nation in the history of the world that's ever done it. We've now had 8 robots operating on Mars. But those, and in fact, 2 of them, Insight and Curiosity, are still active on Mars, helping us get the science that we're going to need for an eventual human mission. But beyond that, I mean, we landed in November of last year. We landed Insight on Mars. Then we took OSIRIS-REx, which was led by a university. This is a robot produced by the University of Arizona. And OSIRIS-REx went out to Bennu, which is an asteroid in deep space. It's now in orbit around Bennu. It's going to grab a piece of Bennu, and it's going to fly back to Earth. For the first time in human history, we're going to do an asteroid return mission, which is going to be transformational. I know that we got the asteroid scientists back there ready to go on that one, too.
It mustn't be a trillion.
Yeah. Okay, yeah. It could bring back trillions of dollars worth of platinum group metals. No, don't count on that. But so an asteroid return mission. Then, of course, we took the New Horizons probe that got the beautiful images of Pluto back in 2015. We sent it into deeper space, the Kuiper belt, which is an asteroid belt well beyond Pluto, and took beautiful images of Ultima Thule, which is an asteroid in deep space 4 billion miles from Earth. First time we've ever been able to investigate something that far from Earth, send those images home. We're still getting amazing science from that. It's a binary contact, basically 2 asteroids that somehow became 1 asteroid, and it looks like a barbell, if you will. And then of course, just a few weeks after that, we had the SpaceX Dragon dock to the International Space Station for the first time, proving automatic rendezvous and docking with a commercial space module capable of carrying humans. So all of these activities, we think about landing on Mars, we think about the asteroid Bennu and asteroid return mission and flyby of Pluto, and then Ultima Thule, and then attaching to with a crew vehicle attaching to the ISS, and they landed this, something a table the size of Mars on, or an object the size of this table on the moon, and all of a sudden we fell behind. Just know this: we're way ahead, and we're getting further ahead every day, and we have the budget and the mandate from the administration to keep moving ahead faster than we've ever moved before. So we're in great shape. There is so much ahead of us. You mentioned Europa and Titan. Why does that matter? I'll tell you why it mattered. I'm going to talk about Mars for just 1 second, and then I'll go to Europa and Titan. Within the last year, just within the last year, we have found complex organic compounds on Mars. The building blocks for life exist on Mars. They don't exist on the moon at all, 0, but they're all over Mars. They're all over Earth, of course, because we got tons of life here, but they're also on Mars, but not on the moon. Does that mean there's life, or there was life on Mars? No, but the probability just went up. Then we found that the methane cycles on Mars are commensurate with the seasons of Mars. Does that mean there's life? No, but the probability just went up. Then we found liquid water, 12 kilometers under the surface of Mars, where the liquid water is protected from the radiation of deep space. Does that mean there's life? No, but the probability just went up. What do we know about liquid water on Earth? Wherever there's liquid water on Earth, there is life. Now we know there's liquid water on Mars. Doesn't mean there's life. I don't know, neither does anybody else. But imagine if there's a day where life is found on another world, and it's not by the United States of America. I think that's going to be a bad day. That's why we're doing these activities. We want the science and the history books to reflect what this country has done. And by the way, when we do it now, we do it with international partners. We lead international partners in these activities. It's a very positive story. But the reason Mars matters is because I really believe the probability of finding life on another world goes up. Mars is the evidence of that. But you mentioned Europa. For people in the room, this is a brilliant audience, I know that. But for those, might be some people that don't know, Europa is a moon of Jupiter. And it is the size of our moon, and it is pure water. I say it's pure. There's other stuff in there, but it's water. The whole world is water. And it's got an ice shell because it's so far from the sun. But the ice shell means that the water inside is protected, the liquid water is protected from the radiation of deep space. And by the way, that water inside we are now seeing, because of Juno and other missions, we're seeing plumes come out of Europa, spray into deep space, water plumes. So the Europa mission, we call it Europa Clipper. We want to get into orbit around Jupiter, fly by Europa, and capture what is in those plumes coming out of Europa, that water coming out of Europa. And then ultimately, we want to do a lander. So we talk about the probability of finding life in our solar system keeps going up. And then Titan, a moon of Saturn. We are sending the world's first interplanetary helicopter. Colonel, you'll like that. The world's first interplanetary helicopter we are sending in 2020 to Mars, the Mars 2020 helicopter. Well, in the mid-2030s, we're going to send a helicopter to Titan. We call it Dragonfly. Titan is a world that is covered, it is absolutely covered in complex organic compounds. We don't necessarily know exactly what it is, but it looks like it could be methane, liquid, some kind of liquid complex organic compounds. Again, there's a lot we need to learn. But I'm starting to believe, in fact, I'll just say definitively, the probability of finding life on another world keeps going up. I'm not saying it's there. I don't know. But why do we do this exploration? Because it will be transformational if we were able to discover that. Did I answer your question?
Yes, thank you.
There's a lot going on that you have to look forward to.
I don't know if he's smart enough to be NASA administrator, but he's enthusiastic enough. And smart enough.
So I think,
I'll do the quick answers from now on.
okay. Yeah, we're just about out of time, so quick question here.
Hi, my name is Jacob Irving. Just thank you both for this opportunity and coming out. My question is about, here on Earth, there's the future seems more unmanned, autonomous, and robotic. But I also see a push in the space side to get more hands-on and people out there. So how do you see either side's role playing out in the future?
It has to be both. So if we're going to send humans deeper into the solar system, they're going to have to work side by side with autonomous systems and robotics. And so I really believe that's why, there's always been at NASA this tension between human spaceflight, which is one department of NASA, and the Science Mission Directorate, which is generally robotics going into deep space or studying the Earth. And there's this tension. You're either for this one or you're for that one. That is fundamentally untrue. You have to have both. And right now, what the moon does is it brings it together. Because when you study the moon, it is in fact planetary science. It's also heliophysics. Because the moon is a repository. We talked about the asteroid impacts. The moon is a repository of subatomic charged particles coming from the sun that hit the moon over billions of years. Those same subatomic charged particles, most of them don't make it through the Earth's magnetosphere. And when they do, it gets jacked up with our very active hydrosphere and geology. But the moon, nothing has changed. The regolith, the surface of the moon, is a repository of the early solar system, our early sun. So the science there is magnificent. So when we go to the moon, it is planetary science. It helps us understand planets. And don't get me wrong, I know that the moon is not a planet. Although I do believe Mars is, or not Mars, but I believe Pluto is a planet. And I've said that very publicly. We got some people clapping in the back.
Trillionaire again.
But so when we think about the moon, we can do planetary science, we can do heliophysics, we can do astrophysics. From the far side of the moon, it's very quiet from an electromagnetic spectrum perspective, which means we can look at very low frequency radio signals, and we can see back to even before the first light in the universe. After the Big Bang, before the first light occurred, we can actually see maybe what the universe looked like. We can do that from the far side of the moon. You can't do it on this side of the moon. So the moon has so many things that bring all of these together, but it's going to require autonomy with humans living and working together, and it's got to be both.
I agree.
Can we do one more?
Yeah, absolutely.
Yeah.
I have a quick question about human factors regarding the Mars mission. Obviously, there are health risks for the astronauts on their flight to Mars, but what are the health risks and what is NASA doing for the sustainability of the astronauts' lives while they're on Mars?
Yeah, it's a big challenge. So just some of the health risks. Large doses of radiation, very damaging. We talk about, astronauts lose 1% to 3% of their bone mass per month when they're in a microgravity environment. It degrades your immune system, so people are more susceptible to illness. We get cranial pressure in the head, which results in optic nerve edema, the swelling of the optic nerve, in some cases the swelling of the brain. And this results in sometimes damage to the eyesight of our astronauts for long periods of time. So what we are doing, we've got really an amazing medical program at NASA that is working to address each of these concerns. Obviously, shielding from radiation is critically important, but it's also true that we need to be able to better predict the sun's activities. When is there going to be a solar flare? When is there going to be some kind of coronal mass ejection that's going to damage our astronauts? A lot of people don't realize If Neil Armstrong and Buzz Aldrin were on the surface of the moon just hours after they were there, they would have been hit with a solar flare that could have very well damaged them permanently. It's basically subatomic charged particles coming from the sun at a high speed and basically pelting them with radiation. And they were fortunate, but back then we didn't know what we didn't know. Now we know. So we have the Parker Solar Probe at the sun. It's flying through the sun's atmosphere, if you can imagine that, which is an amazing capability. And then we just announced just a few weeks ago some new missions that are going to help us understand the interaction between the sun and the Earth's magnetosphere, and eventually inform how magnetic fields can help protect and or cause problems with the radiation coming from the sun. So NASA has a number of missions that are heliophysics in nature, planetary science in nature, that are going to help us better understand the interaction with those subatomic charged particles and how we could protect our astronauts, predict those events so that we can warn our astronauts and have them take shelter, those kind of activities. But from a medicine perspective, we're developing capabilities in medicines for these activities. And what we're finding, this is even more cool, these medicines have applications for people on Earth. So if we're working on optic nerve edema, for example, or swelling of the brain inside the cranium, if we're working on those things, those things happen to people on Earth, people in car accidents, things like that, and we're now applying NASA medicine to those cases as well. So we have a very robust medical department at NASA. And they make sure that our astronauts are physically ready to go, and that they're protected. And there's, again, no shortage of work to be done there as well for the future. I know I said I'd be shorter. I know that's the last question.
You were.
Okay, let me just say, can I close it out?
Certainly.
I just want to say it's been great, Senator. Thank you for having me here. Again, if you ever call, I'll be there. You've been a good friend for a long time. The University of North Dakota is a great resource for NASA. What happens here is going to enable us to do more than we've ever done before. There's no shortage of work to be done, and I fully anticipate that the University of North Dakota is going to be very involved in our future activities, especially when it comes to human spaceflight. The question about lives and taking care of lives in space, that's really what we're talking about with this Mars analog habitat and now these spacesuits. These spacesuits are very complex. Every spacesuit is, in fact, a spaceship. You know that. I mean, this audience knows that. It's very difficult to put together, very difficult to match it to the individual that wears it. The research that's being done here is second to none, and we're very grateful for everything that you guys do for NASA and look forward to working with all of you in the future. So, Senator, thank you for having me. Colonel, thank you for having me and your leadership. And we look forward to coming back in the future.
Thank you. Thank you to both of you.
And by the way, the senator said at the beginning, he said, look, I want all the questions directed at you because this is a rare opportunity. So I didn't mean to steal all of his thunder.
I hope you did.
Okay.